Hey guys, Mr. Brown here, and this video is a bit of a supplemental video to the Calorimetry Lab video. In that video, there's a skip where I explain how to determine the heat capacity of the calorimeter, and this extra video here will go back and redo that. So I have the data that I have determined for the heat capacitor by dumping some hot water into some cold water and measuring the temperature change over a matter of about 10 minutes. And then we graphed that temperature change and used an extrapolation to determine the temperature of the mixture right at the moment they are mixed, which is known as temperature at time zero from the graph, and we see that here is 50.3 degrees Celsius. So for my experiment, when I mixed the 77-degree water with the 24-degree water, it immediately became 50.3 degrees Celsius. And I'm going to try to figure out how much energy went into the calorimeter instead of the cold water. And so what we're going to do is first figure out how much heat energy was released from the hot water. And to do that, we use the equation of Q the hot water. Q the hot water is always MC delta T. And we had 50 grams of hot water. The specific heat of water is 4.18. And the change in the hot water for me is the hot water started at 77 degrees and ended up at 50.3 degrees Celsius. And we know that the change in something is always final minus initial. So in this case, it would be 50.3 minus 77 degrees Celsius. And so the energy lost by my hot water, I would just punch that in my calculator, 50 times 4.18 times 50.3 minus 77. Make sure to put that in parentheses so that the calculator gets the order of operations right. So the hot water in my case lost, indicated by the negative sign, 5,580.3 joules of energy. All right, so the next question I have is, well, how much energy did the cold water gain? And to determine how much energy the cold water gained, I'm going to write Q of the cold water is also equal to MC delta T. There was 50 grams of cold water. Liquid water always has a specific heat of 4.18 joules per gram degree Celsius. And my cold water had a temperature change of starting at 24 degrees Celsius and rising to 50.3 degrees Celsius. So its difference in temperature will be 50.3 minus 24. And so that's going to give us a positive number and indicate that we gained some amount of energy in our cold water. So our cold water gained 50 times 4.18 times, use a parentheses, 50.3 minus 24. Our cold water gained 5,496.7 5,496.7 joules of energy. All right, so now we can have a picture of kind of what went on here. When we mixed our hot water and our cold water together, the hot water went directly from a temperature of 77 to 50.3, and the cold water went directly from a temperature of 24 to 50.3. In that process, or to do that, the hot water lost 5,580.3 joules of energy, And the cold water gained 5,496.7 joules of that energy. Where did the other, so there's a difference there. There's about 84 joules of difference there that went somewhere. We can't lose energy. Energy is never destroyed. So we didn't just lose the energy. It had to go somewhere. It went into the cup. And that's what we're trying to correct for in our further experiments, is that energy that goes into the cup. In calorimetry, we don't want to lose the energy to our surroundings, but it does happen a little bit. And so we have to correct for that. So to figure out this box right here, we are going to find the difference between these two numbers. How much energy our hot water lost versus how much energy our hot water gained. In my case, I will do 5,580 or negative 5,500. You can so you want to subtract one of these numbers from the other. You can do 5,580 minus 5,496.7 to get 83.3. And notice that I didn't use a negative 5,580.3 right there. We want to always end up with a positive number right here. And if I did negative 5,580 minus negative 5,496.7, that's going to end up with a very large negative number. So you just want the difference between these two numbers, how far apart they are, and you want that to be a positive value. So these two numbers are 83.3 joules apart, and we know that 83.3 went into the cup. So since the cup gained that energy, we want to represent that as a positive number. So that's 83.3. In our further experiments, so this number here is exclusive to our experiments. In our further experiments, our temperature changes will be different. So we will lose different amounts of energy to our cup. And so we want to correct for every degree of temperature change. So to figure out this box here, heat capacity per degree Celsius, I will take the figure that I have here, the 83.3, and I will divide it by the total temperature change of the cup. And so the cup's temperature change should be the same as the cold water's temperature change, which was 50.3 minus 24. When I calculate that all the way out, 83.3 divided by 50.3 minus 24 in parentheses, the result comes to 3.12. So I know the heat capacity of my calorimeter is about 3.12 joules per degree Celsius. So we would do that experiment. We've done it one time. You guys will do it again a second time down this column here. And you will get another number here that should represent the same value just measured a second time. And then down here, you will measure those two values to arrive at the average heat capacity, joules per gram degree Celsius of your calorimeter. Thank you for watching. I hope this helps you complete the calorimetry lab.